Hello everyone, welcome to Computer Forensics Assignment 5. This assignment is based on cryptography and this assignment is divided into two parts. The first one will be sample password cracking and the second one is encrypted file system creation and analysis using the Linux Unified Key Setup. So before going into our assignment, let me just give you a brief introduction of how the system stores the password. Whenever a system is storing the password, it doesn't store directly the password. Instead, it stores it in the form of hash, and also it doesn't store everything like the username and the hash value in the same file. What it does, it basically splits the username and password hash into two different files. In first file, it stores the username, a placeholder, which we will discuss about it in the later part of the video, and then it stores the field ID and group ID, which is like a unique ID that the system generates for every user. And also in the second file, the system stores the hash value and also the field and group IDs. And whenever the system needs to authenticate a user, what it does is basically pulls both the files and then it combines both the files and then gets a third file which contains both the username and also hash value of the password. So that's the introduction, and coming into our assignment, the first part is password cracking and encrypted archive recovery. So we have an investigative scenario here. So imagine you are a digital forensics investigator who has been given two sets of evidence from a suspect's workstation. The first one will be a file, zip file, and next we will be given these two files that we have just discussed, that is a suspect password and also the suspect hash, which were recovered from the suspect's hard drive. So, and we have a hypothesis here, that is the suspect reused the system password, that is the password from his main account, to encrypt the file that is stored in his system. So what we will be doing is to conduct a forensics analysis to crack the user's password hash first, and then use that password to unlock the zip file and recover its contents. So what we will be doing is, first we will be replicating the suspect's workstation. So that will be the first thing that we need to do, and then we will continue with the lab, that is like cracking the password. So first let me just open my virtual machine, and so I'm creating a directory called assignment 5 and I'm opening the directory. So next we will be creating both the files that we have discussed, where the system stores the username and password. So this is the file where the system stores the password, a placeholder. Actually this placeholder, it is as you know, placeholder is just a variable where some other value can be stored. So what happens is, whenever the third file is generated, the hash from the second file just gets stored in the placeholder. So that's how it works. And next let me just create the second file which contains the hash value. So now we have both the files, and next, to replicate the suspect's system, we need a zip file, and before creating a zip file we need some contents in the zip file. So I'm creating this text file, So now we have the text file, and now we will be zipping the file with a password. It's asking for the password, and as we have seen in our investigative scenario, the suspect has used the same password as his system password to protect the zip file. So we will be using the same password throughout the assignment, and to keep it simple, we are just using the word password as the password, and we need to enter it again. So now you can see a zip file is created. Now what we need to do is we need to delete the text file, this text file, trade secrets text file. So if you see now, we have both the system files and also the zip file as mentioned in our investigative scenario. Now we have our data set, and also like we can verify the integrity, like calculate the SHA-256 sum of the zip file. So this is the SHA-256 hash value.